Alright guys, so welcome to lesson 6. We're going to talk about systems of equations with quadratics. Okay, now if you guys forgot what a system of equations is, a system of equations is where you have two or more equations. This, for instance. And we want to find out what point do they have in common. In other words, what can I plug in for x so that whenever I get a y value, that same x and y value will work for this equation also. And there were three ways that we talked about to solve it. One way is by graphing. You just graph both of them, and you can find where they cross. And that would be the x and y value that they have in common. The other way is the substitution method, where you find the lonely letter, circle what it equals, and plug it in, and solve. The other method was the elimination method, where you pick a variable to cancel. You flip and distribute the coefficients, change the signs, and then combine down to cancel out. Those are the graphing, substitution, and elimination methods that we learned back in Unit 1 about a month or two ago. Okay, well, we're going to do that again. It's just that this time we're not going to do it with linear equations. We're going to do it with quadratics. Okay, and so by the end of the day, you should be able to find where a parabola intersects a line or another parabola. In other words, we're solving a quadratic system of equations. Okay, now when it comes to quadratics, their systems of equations can look a little bit different, okay, because of the shape of their graph. When we were talking about linear systems of equations, just two straight lines, they either had one place they crossed, and therefore one solution, or they were parallel and they didn't have a solution at all because they never crossed. But when you're dealing with quadratics, the shape of the graph allows for more possibilities than that. You can still get a no solution where they don't hit each other at all, or you could have one solution where they graze each other and just touch at one point, or you could actually have two solutions where it hits twice. But that's pretty much the most you're going to get out of it. Either none, one, or two. And the same thing applies where if instead of doing a system of a quadratic with a linear, you could also do a system with two quadratics. And once again, two quadratics may not touch at all, so that's no solution. Or they may touch at only one point and have only one solution. Or they may touch at 2 points and have two solutions. So we're going to look at both types today. We're going to do systems of equations where we ask, okay, where does the parabola touch the straight line? And we're also going to look at where do the two parabolas touch. But in either way, these are what we call nonlinear systems of equations because we are doing a system of equations but with a nonlinear graph like a quadratic. Remember, linear means straight line. Nonlinear means non-straight line. So the first thing I want us to do is I want you guys to estimate the solutions to this system of equations. Now remember, the solution is where the lines cross and it's a point, so you need an x and a y value. So I want you guys to estimate the solution, or perhaps I should say solutions, of this system of equations. So pause the video and give it a try, and when you unpause it, we'll discuss the answer. Alright, so here we go. We have a blue parabola and a red parabola, and I'm asking you to estimate the solution. And the solution is where they cross. So they cross right here. Now you have to estimate, okay? We don't really know exactly what that is. But I could tell by the way that they've labeled this graph, if this is 4, then this is going to be 2. So the graph's going by 2s, which would mean 1's probably right about here. So I would say this point has an x value of 1 and a y value of 4. So my first solution to the system is 1, 4. Or another way you could write that answer is by saying x equals 1 and y equals 4. Okay? But there's another solution. There's also one over here. There's another place where they cross. So this is 4, 6, 8, 10. So this point is right in the middle. So I'm gonna guess that to be about 9. Okay? And the height, once again, is 4. So another solution to this system is 9, 4, or in other words, x equals 9 and y equals 4. So there are two solutions to this system of equations, or 2 points where the two graphs cross. right? Now that's a graphical perspective, and if you wanted to go through the trouble of graphing these, you could. You could graph this parabola using what we learned back in, I think it was lesson. Actually, you know, I don't know if we have learned how to graph the standard forms yet, but if we have, anyway, you can graph that. And we also know how to graph y equals mx plus b, and you could take an estimation of where they cross. But we're going to handle this one a little bit differently. We're going to handle this using the method of substitution. That's pretty much the only one I plan on using, just so you guys know for today. It's possible to use elimination, but it's a little bit less friendly than substitution, and so we're just going to stick with substitution. Okay, so here's the method we're going to use. We're going to find the lonely letter. That out. Find the isolated variable, which, by the way, you guys, is always going to be y for these types of problems. So find the isolated variable, circle what it equals, and plug that into the other equation for y. Now, usually, it's whatever variable you were working with on number 1, whatever isolated variable it was. But in this case, like I said, for us, it's going to be the y variable every time for this particular lesson. Put that in parentheses here. And now if I do that, if I take what y equals, which is negative x plus 1, and plug that in here for this y, then this is what I'm going to get by the time I'm on step 3. Right? Now, since we're dealing with quadratics, not linears, but quadratics, the next step is to solve it. But to do that, we need to keep in mind a few things. First of all, we need to move everything to one side. Okay, so let me show you what I mean by that. I'm going to add the x here. That didn't turn out well. I'm going to add the x to both sides like this. So now the x's cancel out. And then I'm going to minus the 4. I want to move everything over to one side. Does it matter which side you move? Not really. I just pick the one that looks easiest to me to do, and I go with that. So I chose to move everything on the right side to the left. Technically, you could do the opposite. All right, so there's that. So move everything to one side. All right, so now the next thing that we're going to do, is sorry, technical difficulties here. Woo, fun times. All right, just a second. Okay, I got over my issue there. So part B, the next thing we want to do is use the quadratic formula to solve the equation. So that's going to be our next step. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I set these things up in a way that we don't end up with weird, funky answers. Every one of them should work out in a nice final answer. So let's go ahead and A and then C. Okay, so we have negative 2 plus or minus the square root of 4 minus a negative 12 and 2 on the bottom. This becomes a plus, and it's 16, and the square root of 16 is 4. So we end up with this. And then we're going to solve both of them. We're going to do negative 2 plus 4, and we're going to do negative 2 minus 4. And when we solve both of these, this one gives me 1, and this one is going to give me negative 3. So I've got two x values. And what that means is that this line crosses the crosses this parabola. This straight line here crosses this parabola in two places. Once at x equals 1, and another time at x equals negative 3. But we still need to find the y values that go with each of those. Okay, so that's our next task, is to find the y values that go with those. So let's add that onto our steps now. So step 5, find the y values for each. Sometimes you'll only have one x, so if you have only one x, then that means you only need to find one y value. But if you have two x's, you have to find both. So we had x equals 1, and we also had x equals negative 3, right? So what you're going to do now to find the y value is you're going to plug in these x values into one of your equations. Now, obviously, pick the one that's easier. I think the one without the square, and it's a lot easier. I'm going to plug in 1 here. So negative 1 plus 4 is 3. And then we're going to repeat that for our other x value that we got. In this case, we're plugging in a negative 3. And the double negatives become a positive. We have 3 plus 4, which is 7. In this case, we get y equals 7. And you can leave your answer like this. It's just these 4 variables circled. But another way you could write your answer, which is actually probably the better way, is to put the x value and the y value that go together. So for instance, when x was 1, y was 3. And so it's just better to write it as a point so you know that those go together. So there's one solution. And then we have the other x value is negative 3, which gave me a y value of 7. And so this is the best way, and I would just say go ahead and write your answer like this. I mean, I would give you credit if you wrote your answer like this, but I think you'll find that you'll be less likely to get confused. You'll do better if you actually just write your answer. Okay, so let me erase all this, and then the last thing I did was I actually made a graph here for you guys to see the actual thing happening. So y equals negative x plus 4 is this blue line. X squared plus x plus 1 is this red parabola. And you can see they're crossing at two spots here, and here are those two spots, which we found by, instead of looking at the graph, we found them by using the substitution method. And what is the substitution method going to be looking like for these? Well, we find the isolated variable, which is always going to be y. We're going to circle what it equals and plug that into the other equation for the y variable. We're going to solve it by moving all the terms to one side and then using the quadratic formula. After that, we're going to find the y values that go with each value. Okay, and so that is how we use the method of substitution to solve a system of equations involving nonlinear functions. All right, so let's go ahead and have you guys try one of these real quick. Matter of fact, I've given you two. Now for your two problems here, number one's a lot like mine. It's just a straight line with a parabola. But number two is two parabolas. But it doesn't really matter. The way that you solve it is exactly the same. So go ahead, pause the video here, and see what you guys get. When you unpause it, you'll see this. All right, so here's our problems here. So here's number one on the left side here. I underlined this y. Here's what it equals, and I plugged it in here to give me x squared plus 4x minus 5 equals that. And then I minus the 2x and 3 on both sides, and it gave me this standard form quadratic here equal to 0. So now I can do the quadratic formula. Here's my work of plugging it in and simplifying. The quadratic formula gives me two x values of 2 and negative 4. And I'm just going to plug each of those x values into one of these equations at the top, and I think the linear one is the easier one. So I just plugged it in here, and I got 7 for the 2, and for the negative 4 I got negative 5. So my two solutions are as follows. Now on the second problem I gave you, something a little odd happened at the end. But the first few steps are all the same. Underline the lonely letter, circle what it equals, and plug it in, and you get 2x squared minus 5x plus 2 equals negative x squared minus 2x. So then I'm going to add the x squared and 2x on both sides so that I get a standard forming quadratic equal to 0. And then I plug it into the quadratic formula, but I noticed something interesting at that point. We ended up with a negative inside the square root. Now when that happens, That's an imaginary answer, which means that there is no solution to the problem. In other words, these two parabolas do not cross. In other words, it's a situation like this one here, where you have two parabolas and they're just not touching at all. Okay, so that is your student practice for the basic idea there. And I put a graph here of the last one so you can see why they're not touching and why the answer came out to be no solution. All right, so who cares about this kind of stuff after all? Well, let's just do a word problem for the heck of it. You know, a comet is whipped around a sun in a path that can be modeled by a quadratic function. Okay, so if we put the sun at the origin and we have this comet coming around, and maybe we can model loosely its path with a parabola. Now, just so you guys know, there's actually a different shape that astronomers use to get the path of a comet, but we're going to go with parabola for now. And then we have Earth, who's we're going to send a satellite out, or a probe, to intercept that comet when it lands right here. So we want our probe to land right here at the same time that the comet lands right there. Okay, so we want it to happen at the same time and at the same place, right? So that way they can meet. Well, if we know an equation to represent this straight line path of our probe, or our satellite that we're sending out, it's not a satellite probe, and then we also have a model to represent the path of the comet, we could set these two equations equal to each other and solve it to figure out at what point they will meet. Okay, and so I mean that's one way. Now it's a little bit unrealistic, and these equation stuff get a lot more complicated in real life, but I'm just giving an example of what's the point of a system of equations. It's just basically to show when two things occur simultaneously. All right, we have one more problem here. Let's go ahead and answer this question then. When would the comet intercept the Earth? Now, for this one, you could do it the way we've been doing it, where you find the lonely letter, you circle what it equals, you plug it in, and then move everything to one side. That'll work just fine. However, we can also do this using Desmos. So what I'm going to encourage you guys to do is see if you can use Desmos to get the correct answer on this problem. Bring up web page here real quick. Let me get you guys to the website. I'll tell you what to do, and you guys see if you can figure out the answer. Now, once again, I'm telling you guys how to do this, not so that you'll do this instead of doing the math that we learned. We did this last class too. Much faster, it's much easier, and pretty much a guaranteed right answer, so why not just do this, right? Well, we're in math, so we're learning how to do math. I want you guys to know how to do this stuff mathematically and not just with technology. However, the technology is extremely helpful and very useful. How do you do this? You're going to graph both of the functions. You're going to graph this one, negative x squared plus 4, and you're going to graph 3x, and then you're going to look at where they're crossing, and you can just find the points that way. So go ahead and try to do it that way. You can also do it the other way using the substitution method if you want to, but this is just another way to do it. So I'll pause the video here, and when you unpause it, you'll see the solution. And there you go. The blue line represents the 3x, and the red line represents the negative x squared plus 4. And you could just click on the place where they're crossing, and it tells you the answer. The answer is 1, 3. So, and you could have done that with our other problems that we did today too. But once again, on your homework and on your test, I still want you to show the work. You're welcome to use the technology to double check yourself, but this is what you should be getting, okay? Anyway, that's where we'll probably be stopping for today, and we'll move on to our next lesson.